Imagine your LLM is asked about your company's refund policy. The model may know a lot about refunds, but it doesn't automatically know your company's latest policy. That's where RAG comes in. RAG stands for Retrieval Augmented Generation. Instead of asking the model to answer from its learned parameters alone, we first retrieve relevant information, provide that information as context, and then ask the model to generate an answer. Why use RAG? Because many applications need information that is private, domain-specific, or frequently changing. Your company documents, product manuals, internal policies, and support knowledge may not be reliably available from the model's original training data. RAG lets you retrieve that information at query time instead of retraining the model every time your documents change. A basic RAG pipeline has two sides. First, the ingestion pipeline prepares your knowledge, clean the documents, split them into chunks, create embeddings, and index them. At query time, embed the user's question, retrieve relevant chunks, put them into the model's context, and generate the answer. First, chunking. Don't blindly put an entire document into the prompt. Split content into meaningful pieces so retrieval can find the information that actually answers the question. But don't assume one chunk size is universally correct. Chunks that are too small can lose context. Chunks that are too large can mix unrelated information. Test the strategy against your real queries. Second, metadata. Don't store only the text. Keep useful information such as tenant, document, version, department, date, or access scope. In a multi-tenant application, access control must be enforced during retrieval. A relevant document is still the wrong document if the user isn't allowed to see it. Third, don't assume vector search wins every query. Exact identifiers, product codes, error messages, and names can benefit from keyword search. Paraphrases can benefit from semantic search. In production, hybrid retrieval can combine both. Evaluate whether hybrid actually improves your dataset and query distribution. Fourth, retrieve broadly, then consider re-ranking. A first-stage retriever can quickly find candidate passages. A re-ranker can score those candidates more carefully and put the strongest evidence first. Don't invite all 50 documents to the meeting. Or retrieved text isn't automatically better. Irrelevant or redundant context can increase token cost and make it harder for the model to focus on the useful evidence. Filter and rank before sending context to the LLM. Next, make the grounding behavior explicit. Tell the model to use the retrieved evidence and avoid inventing unsupported facts. But remember, a prompt is a guardrail, not a mathematical guarantee. For applications where trust matters, preserve document identifiers and return citations with the answer. That lets users inspect the evidence instead of blindly trusting the generated text. Here's the important engineering insight. RAG is not just put embeddings in a vector database, it's a pipeline. Data preparation, chunking, metadata, retrieval, filtering, re-ranking, prompting, generation, and evaluation can all affect the final answer. And evaluate retrieval separately from generation. If the right document never reaches the model, changing the prompt won't magically fix the system. Build a test set of realistic questions and measure whether relevant evidence is being retrieved. And evaluate the complete pipeline. Was the answer supported by the retrieved evidence?